Okay, so cycle 2, day 6, ratio, rates, and proportions. So a ratio is a comparison between two or more quantities with the same units. So for example, 4 centimeters to 3 centimeters and 4 to 3. Notice that they have the same units. Either there's no units or centimeter. It could have been centimeter squared, centimeter cube, and etc. We can express ratios in different ways using words. So for example, if you had 5 cookies to 3 cookies. So we're using words, right? Colon notation. So 5 to 3. And so that's how I read my colon as 5 to 3. But we're going to use those dot dots, the colon. And meanwhile, we can write the colon notation as a fraction notation by putting the first number on top as the numerator and the second part as a denominator. And so as a fraction notation, it's 5 divided by 3. Like fractions, it is useful to express our ratios in lowest terms. Ratios are considered to be in simplest form. When the terms of the ratio cannot be divided evenly by any number than 1, and they do not involve any decimals or fractions. So for example, express the following in simplest form: 18 to 12, 25 to 40, 27 to 21. So notice that there are factors that you can that these have in common. So between 18 and 12, what is the greatest common factor that you can divide both by? So consider the greatest common factor, or GCF. So a portion is a statement that tells us two ratios are equivalent. So 5 over 12 equals 10 over 24, or 5 to 12 equals 10 to 24. It's telling us that these ratios are proportionate, right? And so, for example, we dealt with some red paint and white paint problem previously over here. And so if you notice, we initially started off with 1 red and 5 white paint, right? So if we start off with that and there was a mistake in that and we want to actually have 5 red to 1 white, well, we can't go back to having one portion of red, right? So we need to add more white to it. And so we would set up a proportion. And why do you think I changed the blue rating as X? Well, because I can't change the number of red, I can't go back to having 1 red. I can't change back in time, right? But keeping the 5 red, I could add more white paint to it. And so I want the proportions to equal, and then you're gonna try to solve. And so we're dealing with some proportion questions here. So over here, we can solve proportion using the cross multiply technique. So over here, so I showed you 2 ways that you can solve it. You could try to use a way that you prefer, but we use the cross multiply because it's gonna be foolproof. It's gonna work every time, and so yeah, we present it as one of the methods. So x to the 3 to 1 to 5, so that is written in the colon notation form. And when you have that as a first step, easiest thing for you to do is to change it to fraction notation so we could deal with it more easily. And so we have x divided by 3 is equal to 1 divided by 5. Well, how do we do cross multiply? Well, we can do cross multiply when we have, let's say, a fraction equals a fraction. There needs to be an equal sign in between. And I can't have things like that or like that in the way, because right now, if I have that, I have a binomial. And so I need to make sure it's a monomial equals a monomial. So something like that. And so I'm going to cross multiply. And I will get, well, x times 5, you're going to literally multiply the numerator and its opposite denominator. And so 5 times x is 5x. 3 times 1 is 3. Am I done? No. So you got to recall, how do you get x by itself? Well, you're doing BEDMAS backwards. And how do you get rid of the 5? Well, the 5 and the x, what are they doing? They're multiplying. What's the opposite of multiplying? Divide. So you're going to divide both by 5. Well, what's 5 divided by 5? Well, 1. So that part cancels out. And so we have x is equal to 3 over 5 as our answer. Next, 4 to 3 equals 10 to x. So we have 4 over 3 equals 10 divided by x. Okay, so write it as fraction notation. You're going to cross multiply. So see how method 2 really wouldn't work? Because it's harder to tell what is 4 multiplying to get 10. Well, like now I'm going to have, I won't have an integer as my answer. I'm going to get a decimal value, right? And so it's like 2 point something. See how you have to guess your way? So that's why we're not doing method 2, which works when we have some, when we have whole numbers as our answers. So we're going to instead do cross multiplying. And so I get, well, 4 times x is 4x, and 3 times 10 is 30. Next step, how do you get x by itself? Well, you're going to divide both by 4 to get rid of the value in front of the x. And I get x is equal to, well, 30 divided by 4. Do I want to keep it that way? Well, you have to do a check on whether 30 or 4 is divisible by a common number. So what is the greatest common factor between 30 and 4? Well, they're both even numbers. So I'm going to divide both by 2, and I get x equals 15 over 2. And generally try to write your answer in fraction form for non-word problems, and leave it in the most reduced form, and usually improper form is fine. Next question. A bean plant grows at a steady pace. In 3 days, it grows 12 centimeters. How much will it have grown in 7 days? So when I read this kind of question, I like to break down the units. So it says in 3 days, it grows 12 centimeters. How much will it grow in 7 days? Notice that I highlighted the ones that said the same unit. And then a bean plant grows at a steady pace. In 3 days, it grows 12 centimeter. So I kind of broke down what kind of information I had. It's a word problem, so I need to write a let statement, meaning if I'm going to introduce any variables like x, I need to tell the reader what I'm talking about. Well, let x represent what? Well, what are we trying to solve for? Let x represent, well, I need to find how much will it have grown in 7 days. So I'm going to just rephrase that. Let x represent how much it grows in 7 days. So that's what I'm solving for. Okay. Next, I need to set up a proportion. So using the initial part. So see how in 3 days it grows 12 centimeters? That's like a statement. Well, that's like you having a ratio. Okay, so that is the ratio of that situation. So what I'm gonna write is in 3 days, it grows 12 centimeters. So I kind of have like an invisible so units in mind. So I'm talking about days on top and centimeter on the bottom to try to break down how I'm going to write my proportion equation. So 3 over 12 is going to equal, well, we're talking about a bean plant that's growing at a steady pace. So it's going to go in a consistent manner, right? And so for 7 days, well, where is the 7 going to go? Is it going to go to the numerator or the denominator? Well, it will need to go to the numerator because my units have to line up. Okay, and so I have, well, do I know how many days it will take to, sorry, how many centimeters it will take to grow in 7 days? No, I don't. I don't know how many centimeters it's going to grow in 7 days. So I'm going to put that as x. And I'm going to solve for x. I have an equation. I have one unknown. That means I can solve for it. So I'm going to cross multiply. I get 3x is equal to 12 times 7, which is 84. And then you want to get x by itself, and you're going to divide by 3. And so therefore, x is equal to, well, 84 divided by 3. Well, 3 goes into 8 twice, and 3 goes into 24 8 times. So that's going to be your answer. X is equal to 28. Before I move on, I just want to make sure you are simplifying your fractions as you go along. So I'm trying to work without a calculator. And so, you don't have to do that, but in my case I am. So when I have that equation, 3 over 12 equals 7 over x, and I'm just resolving it. Keep in mind, I could have simplified things before I moved on so that I didn't have to put a strain in my head, right? So what fractions reduce? You should be saying, well, 3 over 12 reduces to 1 over 4. Well, that way, when I do my cross multiplication, I have simpler numbers to work with. So see how I made a mistake when I did it the first time in the blue writing? So I should be able to make less mistakes as if I'm able to reduce and then go on. So cross multiplying, I have, well, 1 times x and 7 times 4. And so 1 times x is x, 7 times 4 is 28. So notice that in both ways, so I'll just say both works. And I'll just write a concluding statement, okay? So the black writing is me simplifying before I go on. That's acceptable. The blue writing, I am just kind of going straight through and solving. And if I didn't simplify in the first step, keep in mind I could have reduced it. No, I couldn't have reduced any further. So my therefore statement is, therefore, it will grow 28 centimeters in 7 days.